Good morning, everybody. I hope you're all doing fine. Here's the thing for today. We are going to be looking at surface areas. And I'm going to say right now, for anybody who's tactile, in other words, you like to do things with your hands and you learn better when something is physically in front of you, I would say go grab a cereal box if you've got one. And I think that might help you to be able to understand one of the things that I'm talking about. So if you go and grab that, and just be ready to pause a couple times as you go through if you want to do that, and a pair of scissors might help you as well. Some of you are good with just seeing and hearing, but if you really are one of those people that needs to actually touch it, please go grab one of those things now. All right, so surface areas of prisms and cylinders. If you remember from before in our definition of a prism basically has the same geometric shape on the top and the bottom, and then you've got flat surfaces on the sides, or in the case of a cylinder, you've got a round curvy side. So when we're looking at the surface area, you're thinking about like the outside of that, and that's why I said the cereal box is a good example, because you've got all the cereal and stuff on the inside, but the box itself that's covering up the cereal is like the surface area. And the area, as you know, is really just taken by knowing how many square units it's going to take to cover that up. So you're really thinking about how many squares it will take to cover up over the top layer of your surface, of your prism or your cylinder. So we're going to take a look, and we're going to think first of all about a rectangular prism or a square prism, in other words, a box. Okay, so when you are looking at your box or your rectangular prism, you have to figure out what your top and bottom is. Okay, and that's a little bit subjective, but just use a traditional, okay, I've got a top and I've got a bottom of my box. The complete surface area would include the top, the bottom, and all the sides. But we're going to start off talking about just the lateral surface area. Okay, the lateral surface area is just the sides as you go around your box or around your rectangular prism or around any kind of prism. Actually, you could have any kind of wacky weirdo shape on the top and the bottom as long as they were the exact same shape. And you can just talk about the area of just the pieces that go around the outside like that. So here's where the cereal box comes in, because I want you to see where the formula comes from for finding the lateral surface area. If you unfold your cereal box, it would look something like this. So if you want to, you can take a pair of scissors and cut along the side, so you open it up and open up the flap on the top and on the bottom. Now on a cereal box, you'd probably have kind of a flap on both sides, but if you just imagine the whole top of the box and the whole bottom, or the whole top of the box and the whole bottom of the box hanging off the bottom, and you've unfolded your cereal box like that so that you've got it all laid out flat, and we're thinking about the surface area of it. Now this folded out version of our geometric figure is called a net. Okay, so if you see in your book them referring to a net, they're talking about the thing that you could fold together to make that three-dimensional figure. So you have this, and it can be folded up. Remember, our word for any of these three-dimensional figures that has polygons for all of the sides is called a polyhedron. So a net could be folded up to make a polyhedron, and really your cereal box is a polyhedron. Okay, you don't really think about it, and those words, you probably don't go, gee, I am going to go get cereal from the polyhedron. Okay, but it really is, when we think about that, is what that is. So we've got these two tabs on the top and the bottom. These would be the top and the bottom of your box, but they're not part of the lateral surface area. The lateral surface area is just the area of this folded out bit right here. Okay, that's the lateral surface area for this particular prism. The top and the bottom are the same shape. So when we really think about it, if we wanted to find this, it's really nothing more than a big rectangle. And even if the top and the bottom were a different shape, it would still be just a big rectangle when you folded it out with a different shape on the top and the bottom. So when you're thinking about this, I want to take a look and think about the lengths of these things, just so that we can kind of get a context for this. If you folded this thing out, however wide this is how wide this is going to be when it's folded out. However wide this is, that's how big this should be. And wow, that's a mistake right there. That should be a B. Okay, so somehow when I was thinking this through, they should both be B's. And we'll get that squared away, because I'm really thinking about the lateral surface area. That's not even the important part right now. But it bothers me when there's a mistake of any kind. This is B and this is B. They're the same length. You've got rectangles, so you can imagine the lengths being the same all the way up. And this length has to match this length. If you think about it folded out, this D has to match this one, and so on and so forth. But let's think for a minute of just this gray shaded in section. Okay, the lateral surface area is really just length times width, or base times height, for this rectangle. If you can imagine, when this was all folded up, A plus B plus C plus D would be the perimeter of the base. Okay, these are the bases. This would be the perimeter of the base, would go all the way around here. And that's why this was a D in the first place, because these two are the same with our rectangle. So A plus B plus C plus D makes our perimeter of our base. And then the height is how tall this is. So base times height would be A plus B plus C plus D times its height. That's what this theorem is stating. The perimeter times the height is going to be your lateral surface area. Now, I could just stop right there and say, okay, you got it. That's it as far as the lesson. We need some examples. But lateral surface area is really just taking the perimeter of the base and multiplying it times the height, because all the prisms can be folded out like this. So let's look at an example. Okay. If I have here's my base, and think about it being folded out. We have the perimeter of the base, and this is the height. So what we're going to do is we're going to take all those sides and add them up. There would be your perimeter. 4 plus 3 plus 4 plus 3 would take you all the way around the base. That's the perimeter of the base. Times the height. Times 8. The lateral surface area. The area for just all the way around out the side of the sides would be the perimeter times the height. Now it is an area, so it's how many squares it would take to cover over the outside. So 14 times 8, 112 square inches for the lateral surface area around that prism. Now it's easy to think about in terms of a box or a rectangular prism, we call it, because the top and bottom are rectangles. It is the same idea whether you have a triangle or a pentagon or a hexagon or whatever you have at the top or the bottom, you have the same idea. You just need to get the perimeter of that base and multiply it times how tall it is. And that gives you your lateral surface area. Make sure the word lateral is in front of it, because if it just says surface area, that includes a little bit more. But our lateral surface area is the perimeter of the base times the height. So I would like you to give that a try and pause and just do that calculation real quick if you are getting it before we check to make sure that you're right. Lateral surface area is perimeter times height. Here's our perimeter. I didn't have to do any crazy math to find this. It's 3 plus 2 plus 2.5. Just adding up the sides all the way around. I don't care if it's a right triangle. I don't care if it's acute or obtuse. I'm not even asking that. Just perimeter. And the height is 7. So your perimeter times your height gives you your lateral surface area. All right, if you have a cylinder might be like an oatmeal box, something like that. If you really needed to cut something up to unfold it, if you don't have anything that you can cut up and unfold, even if you just take a piece of paper and you make it into like a circle, and you can imagine that that's your cylinder. But then it's very easy to imagine unrolling that paper and doing the same thing and applying the same concept. The lateral surface area of a right cylinder, okay, ones that are nice and straight up and down, not the crazy ones that go sideways, is the circumference times the height. Because think about that paper that you had. If you unrolled it, okay, it would be flat. It would have a top and it would have a bottom, just like our other one, and you'd have a base times a height, because you've just got nothing more than a rectangle when you unroll a cylinder. And so the circumference of the circle is really the base. It's really the perimeter of the base, the distance around the base of your cylinder. Okay, so the cylinder's just same idea. We could have just left it at one formula. It's still the perimeter of the base times the height. So for this example, we have a right circular cylinder, which means it's got a circle on the top and bottom, and it's nice and straight and tall. It's not squished over. And so we need to use that formula that you have. The lateral surface area is the circumference of the base times the height. Circumference, we remember, is 2 pi r. So I have 2 times pi times 4, which is 8 pi. There's two ways that you could handle it. The problem could say round your answer to the nearest tenth, or it could be give your answer in terms of pi. And either one would be fine depending on what the question is asking. Here our height is 9, so you're really just taking 8 pi times 9, 72 centimeters squared. If your answer were asking to give that value right there, you can do 72 times pi, 72 times pi, 226.2 if you're rounding it to the tenths place, square centimeters, or if you're using a regular plain old calculator that you can find anywhere, there's usually a scientific mode where you could take 72 times pi, 226.19. Oh wow, it gave me the same answer. That's great. Or if you don't like that and you like to simplify your life, you could take 72 times 3.14, and it'll get you pretty close. Oops, and I did 2 equals, sorry about that. So 72 times 3.14, and 226.1 in this case. So it's close enough, and I'd be able to look and give a little grace as far as which number you gave, but it's around 226. And those extra digits of pi bounce it up just another part of a tenth. All right, so once again, you're really just dealing with a rectangle here, but it's what are the pieces of the rectangle? And hopefully that's not going to bother anybody. Now, when it just says the surface area, it doesn't just include the lateral part. It includes the lateral part plus those top and bottom pieces. So when you figure out the area of an entire prism, you're looking at the area of the lateral surface plus a top and a bottom. So that's why 2b. B is the area of the bases. So you need to have the lateral surface area and then the top and the bottom added on to that. So here we're back to our same original prism. We already found the lateral surface area. So I can just pop that right up there. There's your lateral surface area. We've done that calculation. That's the same. That's L. Capital B is the area of the base, because we need to get this bottom piece and this top piece. So the area of the base, this is a rectangle, so it's simply 4 times 3. Area of the base, length times width, 4 times 3 gives you 12. So you've got 12 for one, but there are 2 of them. So our surface area for the entire prism is our lateral plus 2 times that 12, because there's 2 of those pieces. And when you do that math out, you get 136 inches squared for the entire surface area of the prism. Now this is most definitely a topic that you will see in SATs and PSATs and college entrance exams, things like that. This is fair game. So knowing the surface area, and then in another section when we talk about volume also, will be important. All right, so there's that. We can go back to that same triangle that we were dealing with in a minute ago, the triangular prism, where you have the base and the height here. Now I did not exactly the same, because I changed this into a right triangle on the bottom to make it just a little bit easier. When you use other formulas for other polygons, you have to remember to use the correct formula, because right now the lateral surface area on this would be pretty simple to find. So we've got 2 things happening here. We need to look at the lateral surface area. That's easy. Here's my perimeter and here's my height. So you would be able to very nicely, 3 plus 4 plus 5, 12. And then 7 is the height, so we have 84 for our lateral surface area. But our base is a little different. Our base is a triangle, so you have to think back to your area of a triangle formula. The thing about these bases is that you have to make sure that you're picking the appropriate formula for whatever the shape is for the top and the bottom. Sometimes in some of the problems they give you the area of the top and the bottom to start with. So you have to look and see what is given to you. If it was shaded in and they didn't want you to calculate it because it was just already given to you, you would need to just go ahead and add in 2 times that number. But if it's a shape that they're giving you the sides of, make sure you use the right formula. Now you're like, okay, well I have a 3 and a 4 and a 5. This is a right triangle. So the base and the height are here and here. if you are thinking about the hypotenuse, that's not really going to be helpful for a base or a height, because if you wanted 5 to be the base, we don't know the height, and that will be a lot more calculations for you. But if you can take that and take this triangle and think of this as the base and this is the height, or this is the base and this is the height, that will work. And you wouldn't have to calculate this piece right here, which would be really actually pretty impossible with the way that this is drawn out. So 1/2 of 12 is 6. So I have a lateral surface area, and I'm adding it times 2 of those triangles for the base, because there's 1, 2 of them. And so I end up with 96 for my surface area of my prism. Same thing works for a cylinder. Lateral surface area plus 2 times the area of the bases. Formula is actually the same. Okay, but once again, your area of your bases are going to be using that formula. Let's go through the process here. One thing at a time. Surface area is the lateral surface area plus 2 of the bases. Sorry for that outburst. My dog gets very excited when anybody moves. So here we go. Back to this. The lateral surface area is the circumference times the height. So the circumference of the circle is 2 pi r. That's your formula. 2 times pi times 4. We have 8 pi. That's our circumference. So the height is 9. So we have 72 pi centimeters. Or we can go ahead and get the approximate 226.2. We've done that part already. So you've got your lateral surface area. That's great, but we can't forget to include our bases. Now our bases, the area of a circle, because we've got a circle on the top and a circle on the bottom, is pi r squared. So when you're trying to use pi r squared, your radius is 4. So we have 16 pi here. But we have 2 of them. So I'm using my 72 pi format for this. You could use either. I have 2 of those 16 pi's, which gives me 104 pi square centimeters for my entire surface area. Or if we wanted to, we could multiply that out. And when we multiply that out, we get 326.7. I can take 104. Hold on. Here we go. 104 times pi. 326.7 square centimeters for our final answer there. And that would be how much surface area there was. You might need paint to cover over a surface area. You might need to coat it with a certain substance. There's various different reasons why you would want to know the surface area for certain things. All right, so now based on the idea that you have different shapes on the top and the bottom, I just want to take a quick minute to remind you that you have a whole bunch of area formulas. I want to run through them very quickly. You might want to make yourself a little list so you have them handy so that you're not scrambling to find the area formulas as you're trying to figure these. So the top and bottom is what these are useful for. Okay, let's look at them one at a time so you're not overwhelmed. The area of a square, as you know, is s squared. So you've got the side times the side, which is the same really as a rectangle or a parallelogram, which is base times height, where the sides are just the same. Area of a triangle we just looked at, that's 1/2 base times height. Just to remind you, if you have a kite or a rhombus, you can take the diagonals and multiply them together, and multiply by half. If you have a trapezoid, your area formula comes out to be 1/2 height times the sum of the bases. Specifically on a regular polygon, we have that apothem. Remember our apothem, 1/2 the apothem times perimeter. That was used rarely, but it is a possibility for you if you find a regular polygon on the bottom, but they give you the apothem and you're trying to find the perimeter. A circle, the area is pi r squared, and that should be a good thing for you to have handy so that when you do problems, you have those area formulas right there for yourself. All right, that's it for today. Have a good day. Keep on doing your best, and I will be very, very glad when we can be back in that classroom and working together on these things. Have a great day, and God bless you.